Is everybody there?
Yeah.
Except he's still not. Berlin is.
We're good.
Rightly? Okay, good. All right, so I'm showing a terminal, and so before the code was in basically one module, like all the code for the backend for all the different components of SageMathCloud. So I'll draw something on the blackboard. It's just going to be one little sort of box for each of the directories that's listed that I just output there. And these are the different node modules, so chunks of code related to SMC now. So there's one called common, and I'll explain what each of these are in a minute. So SMC common dash node, SMC hub, SMC web app, and SMC local hub. And some of these may in the future be broken up further, but it would be daunting to break them up too much at once. Okay, so SMC common is some collection of pure JavaScript code, all written in CoffeeScript though, that gets used pretty much in every other place. Okay, so for example, there's a bunch of miscellaneous functionality. There's a file misc.coffee that's in here. And if you look inside this directory, which I'll do right now, so common means it's used by everything. Another name might have been SMC util or something like that. If I type, let's see, let me just do ls-1 so it's in a row. There's some CoffeeScript files, and so I mean, this stuff is basically miscellaneous stuff, but also just stuff that's shared between the front end and the back end and everywhere else. Okay, so it's not small. The main point is that it's shared. So the main property is that it's shared by everybody. Almost everybody uses it, and in some way, and it's sort of pure JavaScript. There's no. The reason that's relevant is that because of node.js, often you'll have JavaScript code that can only be run on a server because it involves sort of like file systems and compiled code or something like that. So this is code, all of which can be run in the browser. It has its own test. So each of these bubbles now has or will, I haven't finished this one, have its own independent test suite. So if you want to test the code that's in here or update the code that this depends on or whatever, it's separate from any of the others. And so, for example, if this depends on some third-party module, we can update the module just for this one to the latest version without having to update it in other things that might also depend on the same module, which will help a lot as far as maintenance goes. As I've discovered in trying to update modules, when all the code is just in one big mess, it's very painful. So, and also, before I had it so that the testing was done in different files. It was all sort of like npm test would run all the tests for everything, and so you'd have to like be very. It was really annoying to just focus on one particular piece at a time, and things like coverage are hard to interpret otherwise. So just to illustrate this, I'm going to type np. Okay, clearly in the screen, npm test. So many people. So I just ran the test suite for this. Did you guys see anything?
Yeah.
Yeah. So it ran 179 tests. They all passed. You might wonder what is being tested. And there's a command coverage, which it runs the test suite, and as it runs the test suite, it looks at which functions are being called, and then gives you a summary at the bottom. As you can see, the coverage is atrocious. Out of all the files in this directory, only one file has any tests at all. And it's not so bad. At least it does have, I guess, some around 70% coverage. There's various metrics of coverage. But none of the other files have any tests at all. The test coverage of SMC is ridiculously bad as compared to, say, Sage. Like in Sage, I think our test coverage is about 96%, even including private methods and stuff. But in SageMathCloud, it's extremely low. And so for each of these, you can do npm test, and it will run the test suite just for that particular module. So this is just common code that's shared amongst various things. And let me quickly give you an overview of the important files in this directory. I'll do ls-1. I'll clear the screen and do ls-1.
What exactly do you mean test? Like, what is it testing?
So when I ran that so they're unit tests, and when I ran npm test just now for this one, it went through and ran a bunch of unit tests that it turned out just involved the file misc.coffee, which is a whole bunch of miscellaneous functions. So it was running tests of those functions. Let me show you what the tests look like. There's a directory test that contains the code that gets executed that has the unit tests in it. And if we look at misc-test.coffee, we can look at some of the tests. So
make sure the functions aren't broken.
Yep. Yep, and that they, so we can look at some of the tests. So there's a function count. So if you look in here, it says the nature of the tests are it, and then you describe the test, and then you actually run the test. So there it is. So it correctly counts the number of occurrences of x and y. So it defines a string x, a string y, and then it runs this function misc.count. Okay? And the idea is that if you were to write, say, some function in misc that maybe, I don't know, like split up a search into a bunch of individual keywords or something like you did, I think, then you would also write a unit test that would go in here, and it would get run regularly. So that when somebody else, or when you later on try to tweak that function to make it faster, hopefully when you break it, you'll notice as a result of the test suite.
Is the test displaying with super weird characters on your screen too in the terminal? Like the description of search split? So it's all garbled in the terminal. Andy wrote something. Oh wait, well I wrote that part.
Yeah, that's exactly the function I was talking about.
That was intentional.
I think that there is
specifically testing weird characters. Okay.
Yeah, JavaScript fortunately has good Unicode support, and therefore one should often in tests actually use Unicode. You can use Unicode characters anywhere, and you should. Unlike, say, Python 2, where it's a pain in the ass. So for example, merge. There's some functionality that's right in the middle of the screen now for merging objects, merging dictionaries in Python language. And this is just some tests that it behaves in a well-defined way. Okay? A project, if somebody is just bored, like the coverage is not 100%, as you can see. If somebody just wanted to sit down and write some tests and try to understand some code, this directory would be the easiest one to start in, and that particular file would be the easiest file. And that's why it has some coverage right now. But it would be, my goal is that all the code is 100, that's here, is 100% covered. It's just a lack of creativity and time that has resulted in it not being very well covered. It also is, I would say, significantly less necessary to have good test coverage when you're like one developer or maybe two, and you're working very closely together. As soon as you have more people, test suite coverage and automated testing becomes incredibly important. So for example, with Sage, where we have typically like 100 people contributing to each release, having a massive test suite is super, super important. Without that, it would be an unbelievable nightmare. It would just die. I mean, it would kill the project if we didn't have a really good test suite. So like, whenever anybody gives us some code, we run like 200,000 tests that are across the entire massive library. And you find that like somebody changes something here and it ends up breaking something way over there. And you'd never know without the test suite. Okay, so let's see. So some of the other files, I'll just give you like a one-sentence description of some of these. So client.coffee, it's one single pure JavaScript file, and it actually defines the API between the web browser, and it doesn't really define, but it implements an API that allows the web browser to communicate with the backend server. That's what client.coffee and also message.coffee, and to some extent, sync string and sync table do. So that's what a lot of the files in here do. They make it so that a web browser, or really anything that can communicate via WebSocket connection. So WebSocket is a single persistent connection between here and a backend Node.js server, which is called hub. There are many of these. This is a Node.js process, which in real life, that is in the actual deployment, there's often about 150 clients connected to one of these hubs. And right now there's 12 hubs running, but I started up a bunch of additional ones today, and some of them only have like 10 or 15 clients. Because it's kind of brutal to take a client and then, delete their connection and make them connect to another one, so the thing isn't perfectly balanced right now. In any case, the files that determine how this connection work are client.coffee, message.coffee, and some other things. But these are the main files. And they're used both by the hub and by the web browser. Client actually is not used by the hub, but message.coffee is used by both of them. Client.coffee currently is not used by the backend over here, but it will be in the near future. So I'm re-architecting things a little bit to make things a little more symmetrical. So if you think about it, by the way, you're sitting there with your web browser using SageMathCloud, right? So your web browser is connected here. There's also a project running somewhere, namely in this case, this Omnibase project. The project is a single Linux account running on some computer at Google. So there are a couple of users right now, namely all of us in this room, for example, connected to that project. And then there's one other user, which is some Linux account on a machine. And that's the actual project. And right now, it's not so symmetrical, but there is, I guess it is. I mean, it's pretty symmetrical, but it could be more symmetrical. It would be nice to make it so that the project is viewed by the hub in a way that's very similar to how the other clients are viewed by the hub. The only difference is really just the security sort of, what a project is allowed to do is, of course, different than what a user is allowed to do. Like, as a user, you're allowed to communicate with all of the projects that you're a collaborator on. Whereas this project, it's sort of allowed to communicate, I guess, with maybe the users that are collaborators on that project, but it can't sort of talk to any other projects. Right now, maybe future that could change. Okay, so this is SMC Common. SMC Common Node is similar, though there's less that uses it. This is code that's shared between various things that run on the back end. So SMC Web App, this is the web application that runs in your web browser, so it doesn't use this code. But the hub will use this code, and the local hub, which is what runs, maybe this should be called project, now that I think about it. Right now it's called local hub. That code also uses stuff here. So what this is it's, basically random miscellaneous functions that I would like to put in here, but I can't because they're not pure JavaScript. They depend on stuff that's special to Node.js. So the sorts of things you find in here are maybe ensure a directory exists on the file system. Or I'd like to run a shell command, like fork the process and run a shell command like ls or something, some like Unix command, and then get the results back. And so that's the sort of thing that you find in here. And there's also a lot of stuff related to sockets. So if you want to connect two processes together over the network and then have them communicate and have some sort of like you don't allow somebody to talk to you unless they know some secret key, then that's the sort of thing that's implemented in here. So it's all about the various node servers talking to each other. So that's what SMC Common Node is. And again, it will have, or actually already has its own test suite, coverage, etc. Go into that directory. Oops. clear ls-1. So here are the relevant files. So there's client node.coffee. Client node.coffee would be a really useful thing to use. I haven't used it in years, actually. What it does is it's a pure Node.js, I guess, class. You run it in Node.js, and it allows you to simulate a web browser and use this same. As far as the hub's concerned, it's just talking to one of these web browser-based clients, but it's actually running in Node.js. So you could do things like basically tests that involve lots of faked web browsers that way. And that's what I originally had it there for, but I haven't used it because worrying about testing has been a low priority. misc-node.coffee, that's where most of the code is. There's also a little SQLite interface. So I do use SQLite a little bit, and I'll tell you about that when I talk about this in the back end of SMC. So you can look at it if you want, or just type, if you type open SQLite.coffee, it'll pop up. Oh, that will not work because I'm SSH'd into another computer. So if you want to open, you have to open a different terminal. So I won't do that. But these files are in ls. If you look at the directory dev0 in the project, it's mounted as this stuff, so you can directly edit all of these files that way. Okay, so that's SMC common. Oh, let me just for fun run the test suite, npm test. So there are no tests at all, and they all passed. Great. Yeah, and I'm sure the coverage is not good. Yeah, it should be 0. There you are. So that's not good at all. Could be improved. I don't know what. Why does it think? I don't know why it seems to give hope, but there's nothing there. Okay, so let's see. The next one let's look at is web app. So this one's really big, and you've surely looked at it before, maybe. Wow, let me just do it like that. Okay, so you should see a big list of files. So now we're looking at SMC web app. This is mostly what used to be the directory page. But is now SMC web app. It's not exactly equal to that, but it's very close to that. Some differences are that it has its own package.json file, which is in Node.js, how you describe what the dependencies are for a module, and a few other things, like what the version is, who the authors are, etc. And the package.json, if you go into this directory and type, like, you type npm install, for example, it will go and install exactly the dependencies needed for the web application. If one was to write, say, an Android app or something else, then you basically, I think at the end of the day, end up with another module like this, which might be Android, which would serve the same purpose as SMC web app. And then we would have like SMC iOS, and then hopefully some common module that they would both use. And they would also possibly draw in some of this code, which we might factor out. Well, we would certainly factor out code from here that we could use by all 3 of these. Okay, so more about SMC web app. So again, like with everything else, it has its own test suite. The tests here, they're not worse than here, but they're pretty close. They're all back-end tests, so they get run in Node.js, even though they're testing something that's sort of, imagine running a web browser. Some of them run by using the React library to sort of to generate what React can generate on the back end, and then doing tests on that. Some of them use JS DOM, which is the JavaScript implementation of the browser DOM, and npm test. But I mean, there really are like, it's probably like 5 tests or something. I don't know. I mean, there are 9 whole tests in this entire thing, and they're in this test directory. So the idea is that we should have lots and lots of tests of, each React component. We should have a test that instantiating it works. Like if you try to create the component, it works. Then we can do various tests on what the state, what happens to the state if you give certain props as input, or what it renders, or whatever. That if you try to render it, it checks the types correctly, stuff like that. But right now there aren't really any tests, as you can see. And regarding coverage, I got it to work, but it only tells you about coverage in the .coffee files. I should say something. In this directory, you'll see that there are files in several different languages or formats. There's HTML files, all of which will go away with the rewrite using React. So right now there are, let's see, HTML. There are 15 HTML files that are a total of 2,483 lines. Yeah, whoops. That's with white space and stuff. So it's not a lot. But this will all go away. There will be one single HTML file left, hopefully, once we've rewritten everything using React. And there used to be a lot more HTML here. Questions? Please. So there used to be a lot more HTML here. So that's one thing. There's CoffeeScript files. Some of which will go away. Yep. But there's also CJSX files. So CJSX, it's CoffeeScript, but in addition, you can put what looks like HTML inside of it, and it will get converted in a very straightforward way from what looks like XML into a bunch of nested function calls. That's how React works. This is a CoffeeScript variant of Facebook's JSX, which is a slight extension to JavaScript, which lets you embed JavaScript, or lets you embed XML right in JavaScript. So that's what the CJSX files are. And there's a lot of those. Probably most of the files in this directory will eventually be CJSX files. So with CoffeeScript, the reason you'd use that instead of CJSX is you're going to write a bunch of code, and it's like just, like you're writing a library for maybe for synchronizing the state of things or something like that. But if you're going to actually do something that involves generating, like actually modifying the page itself, you're probably going to be using React, and then you'll end up writing a CJSX file. Okay?
What's XML used for?
When I say XML, I just think HTML. It looks like HTML, except it's not HTML in that it has to be valid XML, and that, like, if you have a tag, you have to have a corresponding closing tag, or you have to put a slash after it. So there's some rules that it has to satisfy. And also because it's CoffeeScript, you have to intent properly. So it's more than just the constraints of XML. It's really cool though. I mean, to put it mildly, it's extremely cool when you use it. In that, like, you basically write a function and you want it to return some like little piece of your web page, basically. So you right there you put the relevant relevant HTML. You'll see a lot of this if you look through the code. And inside of the CJSX, so let's say you make an A tag, and you want this to be you want the href to be the value of some variable, say foo. What you do is you put href equals and then braces foo, like that. So you use braces to escape from HTML back to CoffeeScript. One nice thing that is very relevant is that during the last week I've rewritten all of this successfully now to use Webpack. And that means that all of the conversions from HTML, CoffeeScript, CJSX, etc., to pure JavaScript, and then the delivery of those converted versions to the browser gets taken care of automatically. So there's a process that just sits there and watches the file system. And when anything changes of any type, it will automatically compile it via the proper sequence of transformations, and then and make it available to the web browser, or possibly send it to the web browser. Though I haven't done much with that yet. Webpack it's very modular. There's like, if we look at package.json, so let's list all of the, actually, sorry, it's the wrong directory. Webpack runs one level up. So if you look, it's hard because we have so many different screens and they're different sizes. So I want to take over. Okay, trying to look at the top of the file, but it's not working. Hopefully you can see that. Okay, so you should see a whole bunch of things that end in loader, like CJSX loader, file loader, HTML loader, JSON loader, etc. Script loader, style loader. What this does with Webpack is it makes it so that right in your CoffeeScript code or CJSX code or whatever, you can just require things. Like you can require a file that's a CSS file or a Sass file or an image or whatever. And for all these different types of files, it will sort of read them, and then it has various things it'll do with them. Like if it's an image, it'll actually inline it if it's up to a certain size, and it's all configurable. And if it's a Sass file, it'll automatically convert it to CSS. So it sort of just automates all of that. And if there's some file type that we want to include and then start requiring, there's almost certainly a Webpack plugin for that, which is an npm module that you install. Yes?
Where does that leave us for like hot loading things?
Um,
You know what I'm talking about?
Yep.
Yeah.
That will be easier after switching to Redux, since Redux explicitly supports that, whereas Flumux I don't think does. So somehow that's relevant.
Hot loading
Flux
is
implementation. Yeah. So there's two different. There's hot loading where it just the second something changes, it refreshes your browser. Like it knows that it changed and refreshes your browser. That's kind of annoying though. But what you really want is that it actually pushes out the modified JavaScript, like the updated React component or something, and then all of the parts of your page that use that React component get replaced by the new version of that React component, so that you don't have to refresh your page at all. And that is something that Webpack plus something called Redux support really well. And I could say a little more about this. I'm planning to rewrite our front end to use Redux instead of Flumux, which is they're two different, more or less they're two different Flux implementations, where Flux is how you store all of your data and synchronize it across your application. But I don't make any claim that so right now, what happens is that let me stop it running over here. So it's very different than it was before, but I mean, you type W. It's exactly like you do before, but what it does is it does npm run webpack watch. And what that does is it runs Webpack with certain options. And the first time, what it does is it looks through the web app and all of the dependencies, of which there are many, like code mirror, everything. And it figures out where the files are. There's hundreds and hundreds of different files. It puts them all together and builds a JavaScript file out of them, or actually builds like 10 different JavaScript files out of them. And if inside of your code you do things like, it has asynchronous module loading, for example. So like, if deep down in your code you do require .ensure, I don't know if I really want to go into the technical details of this, but you can do require.ensure and then do some requires in here. And you can make it so that it will automatically generate extra .js files that it will automatically download exactly when you try to require certain code. And so that is the way, it's a way of solving the problem of, so every time we add a new editor to SageMathCloud, maybe it's, like, what if a new editor, like the course editor, for example, is like 300, 400 kilobytes maybe. So it's actually really, really big. I'm maybe exaggerating, but imagine it's that big. Then it's kind of annoying if every single time anyone opens the SMC website just to like sign up or look at a Sage worksheet or something, that they have to also load the code for that. But with Webpack, it's completely unnecessary. All you have to do is do require.ensure, and then you can make it so it dynamically loads modules exactly when you request them. And it will automatically analyze your code, split it up into bits, and then load various chunks on demand at the right moments. And I did implement this for the course editor and a couple of other things, just to make sure I understood how it worked. So if you look in demo.term, you'll see that it took over 20 seconds the first time. And during that time, instead of basically doing a similar thing with the old, browserify and uglify JS stuff that I had would take like 10 seconds. This takes 20 seconds. But now if we modify a file, so I'm going to, actually can somebody just modify any file in SMC web app? Maybe one person can volunteer to do this, so we don't all do it at once.
Somebody call 911.
Okay, who wants to modify a file in SMC web app? Whoa, what just happened? Why did somebody exit it? No, you can't. The whole point is you have to modify the file with this thing running. So stop. Whoever's doing that, stop.
Yeah, I'll just run.
Stop. I want to start this running, which takes 20 seconds. It analyzes everything. Every possible dependency, everything gets analyzed, like beyond the whole tree, which takes a while. But then it sits there and just watches. And the second you change a file, it will do all the right things as a result of that. Any type of file, like anything like SAS files, CoffeeScript files, CJSX files, everything. And it's quicker. It's quite quick. So it's often like a half second. So that's really good. So is anybody going to change something? Just, you could, if you just look at the file listing, you could open something that's in dev0, for example. You see, nobody's doing that. Okay, then I'll change something. So I'm just going to change, you can't see what I'm typing, but I'll change, I don't know, account.coffee, say. So I deleted a line of account.coffee. And then right when I did that, it should notice that I did that. Actually, it might not because it's such a stupid thing. It doesn't have to generate any different code. It's very smart. So I'll change it. I deleted a line and then I put in a line that said console.log hi. Okay? So now if you look at demo.term at the bottom, you should see it says that it built landing.js. So it rebuilt one of the many JavaScript files. There's a whole bunch. There's like 10 different JavaScript files that it's built, which load in asynchronously various pieces of the page. But landing is like the landing, that's like the top level. Like right when you go to the site, that's what you get. Now it'll be landing.js and a couple other things. But the point is that it just sits there watching the file system, and whenever you make a change, in less than a second in most cases, it's updated the JavaScript. And then you have to refresh still, but there is support for not even having to refresh coming soon that people have developed. And I'm putting everything in place so that we can easily use that support. It should make development very, very pleasant. Because, React, the way pieces of the page work is it's sort of like extremely easy to have it just slot in a new version of some JavaScript code and then redraw that piece of the page, which is just totally awesome. Okay, so there's that. So now just a quick overview of what's actually in here. Web app. Okay, so I've typed ls in the demo.term directory. So there's a whole bunch of different types of files. It's pretty hard to go into detail because there's so many of them. All right, well, Nick and John understand all this code, so you can ask them.
Yeah, I think it's like
right? It's the one code you understand the best. So.
Yeah, I feel like the people who need to know it, and the people who don't need to know it.
Okay, I will skip saying much more. Let's see. Yeah, this is the interesting stuff where we need to do a lot of work, basically, because if anything, I want I haven't talked about this yet, but I'll go over it in a moment. I want this to somehow get smaller, and I don't want this to get much bigger. But I think the real interesting stuff is here, and then of course here and here at some point, but it's really here. Because here, this is, like all the backend stuff, like this is just, stuff that's necessary to write this. The backend server, you kind of want that you want to basically build some clean abstractions that you can build this on, and then don't have, as much as possible when you're implementing new things, for users, you don't have to change the backend server. That's kind of my goal. And I dramatically changed the architecture this summer to enable that. And I think it worked pretty well as far as making it so that you rarely have to change the backend server. Yes?
In what cases when you're like working with like things in SMC web app, like in what cases will you, like let's say you change something or you add in something, in what cases will it require you to change the backend? Like you just said you would want to have like a strong backend that you don't need to.
Yeah, exactly. Yep.
And what would be an example of something that would like need to alter?
So it used to be that there's this file message.coffee, and it used to be absolutely massive. So basically a huge number of different things you'd want to accomplish, like at the beginning, in fact, much worse than even at the beginning of the summer, like kind of anything you do in the web app almost that would involve the server in any way, like change a character in a file, add a collaborator to a project. Every single thing had a separate message for it. Okay, so there's just a huge number of different JSON messages all defined in this file. And so if you wanted to do something like, I'd like to make the collaborator search slightly different or something like that, you have to change the message format. And then in client.coffee, for every message, there was basically some function there that would put the data in your message in an appropriate form and then send it off to the hub. The hub would handle that message and then maybe forward it off somewhere else, and then it would get a message back, and then it would send the message back, and then the client would deal with that, and then you would see it. So frequently you'd have to change code in in possibly 4 different places just to implement something. The abstraction now that most things are implemented on is the following. Basically inside of imagine you had a table, just a list of JSON documents, okay? So JSON documents. So what I mean by that is very simple JavaScript objects that you can JSON stringify. So imagine you have a relatively small table consisting of such documents where each one has a primary key. So there's one key that every document has. It could just be an ID or something, and that uniquely determines that document. And now imagine that that document can be shared between many web browsers and also the backend, and then possibly also the projects themselves. Okay? An example of such a table might be an example of one of these is for a project. There's a document that describes that project, and it has in it a list of the collaborators on the project. So there are 2 different ways you could implement add a collaborator to a project. One way would be that you define a message, which is add collaborator, and then you have a little API function in here which you call that adds a collaborator, and then it sends that message, and then Hub has something that handles the add collaborator method. The other option, which is what it now is done, is you just modify it. You say, hey, I'd like to change this table, take the row that corresponds to my project, and just add the following person as a collaborator. Slightly modify that document. And there's some code that's in here. Well, it doesn't matter where it is, but there's some code that generically deals with modifying documents and the permissions that are related to that. And so now a huge amount of stuff in SMC is accomplished by simply modifying an entry in a list of JSON documents table. So this is called a table, a synchronized table. So you modify the thing which is the list of your collaborators, and then that gets sent to the hub. The hub doesn't really know about collaborators per se, but it checks to see if you're allowed to make the change that you just requested to make, and then if so, it actually makes it in the database. When the database changes, any other hub that has a user connected to it that should know about that change will get a push message saying, hey, this table changed, and then this sort of table will get synchronized. So basically, everything, as much as possible now, is done via synchronized tables, which are sitting in memory in each of the browsers. And if you want to see a list of all the actual synchronized tables, they're in one single file called schema.coffee, which is sitting in here. So everything about all of these tables is defined in that one single file. All the rules for how they work, how the permissions work, everything is in that one file. And if something is, often you can implement functionality that you want just by taking something that's already there and then writing some code to modify an appropriate table, and then it just does what you want. So like, well, in any case, and that's the difference. Does that make sense? And so instead of having to change the server and the messages and the API and stuff, every single time you want to do something with, say, this, like, say you want to add a new field that says that a project is associated to some course that somebody's teaching. That's not in there right now. But if we wanted to add that, we would just modify the file schema.coffee to add a new field to the projects table, which is something like is in a course, and it would have the corresponding course project. So you just add that. It would be like you just add like one line to this file. Then you would add some rules that say that explain how you can, who's allowed to change that field, and some other stuff about it. And then everybody then has that field listed in their list of projects. And the hub doesn't know the difference. The hub, which is right here, this backend server, it just, the only difference as far as it's concerned is the file schema.coffee was updated. And it's a pretty simple format, I hope. Basically, I've extended it enough to handle everything that we need to handle. If it turns out there's something else that isn't covered by this, then we can add it. But by the way, the idea for this approach, which is instead of having an API with a huge number of different types of messages that go back and forth, instead you have this sort of declarative description of a bunch of tables, and then everybody can change them. It's basically inspired by Facebook's relay architecture in GraphQL. So I'll just say Facebook's GraphQL / relay, which is something they, I guess, open sourced sometime in the last few months. It didn't exist except as something they announced that they would open source at the beginning of the summer. I think they only released it maybe 2 months ago. And by that time, it was way too late to use it itself. But I'm kind of glad because it turns out it's extremely complicated compared to what we need. So I don't think it would be so good to use. It's like the way it works is a lot different than what we're doing, as it turns out. Okay, so so the abstraction on which everything gets built is the idea of a synchronized document store that you get that's synchronized between the front end and the back end, and it's defined by some conditions. Okay, and you can think of the hub as the point of what the hub does. So this is the next thing. Let's move on to this cd.smc hub. There aren't very many files here, and actually most of them don't. Let's see. Let me clear the screen and just show you the ones that end in .coffee. Okay, so there's compute.coffee, email.coffee, hub.coffee, invoice.coffee, rethink.coffee, sage.coffee, and gcloud.coffee. Hub.coffee is a ridiculously large file. Sadly large. You can see it's 263K. So yeah, yeah. So it's really big, and I've tried to shrink it a lot over the summer, but it's one single file, and it relies on compute.coffee, and basically it requires these other files as well. So it's kind of big, but it runs this server, and what it does is it's a Node.js server. There's a whole bunch of them running at the same time, and it provides. Basically, it's the thing that you connect to via WebSocket, and it sits there and receives messages and responds. And it's responsible for deciding who can do what, and it also implements this table thing. So as far as the picture goes, you have the hub, and it's talking to databases. But really, it's a lot of different hubs. The hubs do not talk to each other directly. There's no communication directly between the hubs. And there's also a lot of different database nodes. So it's kind of like, this is really the architecture. And there's actually 6 databases right now and 12 hubs right now. And the web browsers, actually client's too generic, so web browser, these web browsers are connected to a hub. When you connect to the site, it chooses one of the hubs somewhat at random, and actually not at random, it looks at, it's kind of stupid, but basically it looks at which hub has the least connections and connects to that. Except it's done locally and there's some DNS load balancing right now, which is kind of stupid, but in any case, it connects via some sort of load balancing via using HA proxy to one of the hubs, and then lots of messages go back and forth here, and many of those messages are just about implementing this notion of synchronized table. So the browser connects and says, hey, give me the table of all of my projects. And then the hub connects to the database and gets the table of all the projects, sends it back to the browser, and it subscribes to a change feed so that if the list of the user's projects changes, then the database will tell the hub that the list of projects changes and what changed, and the hub will then tell the browser that something changed in the list of projects. It sends little diffs, basically. And so, as I mentioned, there's no communication at all between the different hubs. So the only way that a user connected to one hub will ever know anything about what happens with, well, if you have 2 different users connected to 2 different hubs, the flow of information always has to go either via the database or via the projects themselves. So the hubs also talk to projects back and forth like that. So I mean, there's a huge amount going on behind the scenes that you don't see when you're just looking at the web app. That's what the picture looks like.
And the project is like a Linux account on Google.
Yep, exactly. Yep. And like that's what you look at when you're looking at your project. Your, say project. It's one single Linux account on a server. So project equals Linux account. Database, these are RethinkDB. And RethinkDB is it's a database that is different than every other database in that instead of, well, basically you can subscribe to a query. So you can say, give me all the things with the following property. And by the way, if anything changes about the result of this query, tell me what changed. So that's what it does. It just, you have a single persistent connection to the database, or actually many, and it pushes the changes. Like every time the result of a query changes, it just tells you that instantly. So it's really cool because, this person changes the person using this browser changes their name. And so then that synchronizes some table. There's a table which is your account information, account info table. So there's a table that's your account information. You say, hey, I'd like to change the name field. Actually, it's the first name or the last name field. And then sends a message to the hub saying, change this thing in this table. The hub doesn't do anything except just verify that you're allowed to do that. Then it tells the database, hey, I'd like to change this entry in the database. The thing changes, and then the database, since the databases are all connected to each other, send messages out to everybody who's supposed to know that the name changed, and then they change sort of in real time. It's like if I'll change my name right now in SMC. So right now it's William A. Stein, and I have my middle initial. So I just got rid of it. You should have seen my name change if you're looking at it somewhere, like in the list of collaborators or something. Like if you look at...
Can you view collaborators from Terminal?
Nope. You have to look at the project and then go to settings. And that's the only place where the collaborators will be listed.
And the project is.
Yep. It's in the settings for the project. So I see many... So I don't know, can you see my name there?
Mm-hmm. Yes.
Yeah, now watch, I'll change my name. So I'll change it back to William A with no middle, with no dot. Okay, I just changed it. Yeah, so did it work? And everything's like that. Change the title of the project. We loved it changing the title of the project, right? So I'll get rid of the word growth. SMC devel omnibase save. Okay, I just changed the title of the project. So again, that everybody should have seen that in the project settings. Did they?
Oh, we have a log notification.
Yeah, and there's also in the log,
That's neat.
right when we did that, everybody should see the log suddenly has a new information about who changed the title. So, and by the way, the log itself is just one of these tables. There's a table called project log, and for every project you create one of these, and then when you want to make a new log entry, all you do is just add a new entry in the table, and then the infrastructure takes care of everything else. So you don't have to worry. Like in order to implement adding a new entry to the table, all you need to do is think, oh, how do I add some? I mean, in order to implement a new log entry, you just add. You do whatever you want. You just add something to the log table. So it's pretty easy if you want to add a new log type. The hard work is that you have to then figure out how you're going to render it. And so you have to make a little React component, maybe that corresponds to the log entry. Okay, so that's the hub. The hub should be refactored quite a bit, but that's not what I'm not going to worry about that in the immediate future. I'm hoping that it will shrink as the good way of, as sort of what I wanted to do becomes very clear, which has, I think, happened. Okay, so local hub is the project itself, and basically the architecture of this is pretty similar to that of the hub. So I'm going to punt on that for the moment, but in your project, there's a single node.js process that starts running. It sits there and listens for connections from the hubs, and multiple hubs can connect to the same project. The project sees itself and is implemented very much like one of the hubs, and it views the hubs as like web browser clients, basically. It's just that it trusts anybody that connects to it, because the only thing that can connect to it is the hub, are these hubs. So, and they're trusted, not you. I'll say more about projects at some point in the future, but not right now, because it would be good to talk about projects. Ooh, fun. Okay, so I've basically finished giving you an overview of the architecture of SMC. Maybe I should take a picture of the screen because somebody who's not here might want to look at this.
Might need a panorama.
I'll just take multiple pictures.
No selfies.
Ooh. All right.
So what percentage of that picture is your face? Less than I thought.
I held it as far away as I could. Andy is very visible. He looks very happy. Okay, good. So that's
Okay.
there. Okay,
That's
the
what
next
you
thing.
did. What are we doing?
Yeah. So the next. Well, so this is a structure, and then the next thing is projects. So I'm gonna basically have you explain stuff, and then I'll just try to summarize it to make sure I understand. Right here, okay? So we can start here. Okay, so who wants to start?
You and me, Ron. So we've been working on analyzing some of the data that you've given us for different purposes. One of the things we did was we calculated the monthly recurring revenue given all the Stripe subscription information,
Mhm.
which paints a fairly nice